Now we solve the next question related to the empirical formula, that is NCERT question 34. In this question, the statement is a welding fuel contains carbon and hydrogen only. On burning a small sample of it in oxygen, it gives 3.38 grams of carbon dioxide and 0.69 gram of water. A volume of 10 liter at NTP of this gas is weight 11.6 gram, and you have to find empirical formula, molecular formula and molecular mass of the gas. In all the questions that we have done up to now, the percentage of elements are given to you. But in this question, percentage of carbon and hydrogen is not given to you. So first of all, we have to find the percentage of carbon and hydrogen so that we can easily find the empirical formula of the compound. So how can we find the percentage of carbon and hydrogen? From this statement, we know that in this gas only carbon and hydrogen elements are present, no other element is present. When carbon burn in oxygen, it produces carbon dioxide. When carbon burns in presence of oxygen, it produces carbon dioxide, and hydrogen burns in air, it produces water. So first of all, in this question, it is given to you 3.38 gram of carbon dioxide is produced. You know that from 12 gram of carbon, the amount of carbon dioxide gas is 44 grams. When we burn 12 grams of carbon, it produces 44 gram of carbon dioxide, and in this question 3.38 gram of carbon dioxide gas is given to you. So from this we can easily calculate the amount of carbon present in this. So put the statement 44 gram of carbon dioxide is produced by 12 gram of carbon. 1 gram of carbon dioxide produces by 12 upon 44, and in this question the amount of carbon dioxide is 3.38 gram. So 12 upon 44 multiply by 3.38. When you solve this, you get the amount of carbon. When we solve this, 12 upon 44 multiply by 3.38, it comes out to be 0.9218 gram. It means this amount is the amount of carbon which is present in the welding fuel. Now in the similar way, we have to calculate the amount of hydrogen present in the welding fuel. From this balanced chemical reaction, when 2 gram of hydrogen burns, it produces 18 gram of water. And in this statement, amount of water is given to you, that is 0.690 gram. So solve the amount of hydrogen present in this welding fuel. How do we calculate? For this, 18 gram of water is produced by 2 grams of hydrogen. 1 gram of water is produced by 2 by 18, and 0.690 gram of water produced by 2 by 18 multiplied by 0.690. When you solve this, you get the amount of hydrogen that is present in this compound, and it comes out to be 0.0766 gram. From this statement, in this statement, amount of carbon dioxide and amount of water is given to us. From this, we have to find the amount of carbon and amount of hydrogen. Our next step is to find percentage of carbon and percentage of hydrogen present in this compound. So I write here the amount of carbon and amount of hydrogen in this compound. In this compound, carbon is 0.9218 gram and hydrogen is 0.0766. Now we have to find the percentage of carbon and hydrogen in this compound. For this, we have to solve. How do we solve this? For percentage of carbon, we know that mass of carbon divided by total mass of the gas multiply by 100. If we solve this, mass of carbon that we have already calculated, mass of gas multiply by 100. If we solve this, it comes out to be the percentage of carbon in this compound. And how do we find the total mass of the gas? As in this gas, only carbon and hydrogen are present, no other elements are present. So for total mass, we add mass of carbon and mass of hydrogen. By doing this, we can easily find the total mass of the gas. So total mass of the gas is 0.9218 plus 0.0766. When you solve this, it comes out to be 0.9984 gram. This is the total mass of the gas. So percentage of carbon is equal to mass of carbon, that is 0.9218 upon total mass, that is 0.09984 multiplied by 100. It comes out to be percentage of carbon, that is 92.33. This is the percentage of percentage of carbon in this fuel. Next, we have to calculate the percentage of hydrogen. Percentage of hydrogen is equal to 100 minus percentage of carbon, that is 100 minus 92.33. It comes out to be approximate 7.67%. From this statement, up to now, we have to find the percentage of carbon and percentage of hydrogen. So our next step after finding percentage is find the empirical formula of the compound. From this, we have already find the percentage of carbon is 92.33% and percentage of hydrogen is 7.67%. Now we have to solve this question for empirical formula. For empirical formula, first of all, we write the number of atoms that are participating. In this compound, only 2 atoms are participating, that are carbon and hydrogen. Next, their percentage that is given to you, or you have already calculated. Percentage of carbon is 92.33 and percentage of hydrogen is 7.67. Next, their atomic mass. We have already known the mass of carbon and hydrogen. The mass of carbon is 12 and mass of hydrogen is 1. Next, we have to find the relative number of moles. For this, divide 92.33 by 12, or percentage composition divided by its atomic mass, that is 92.33 divided by 12. If we solve this, it comes out to be 7.69. Next, for relative number of the moles of hydrogen, it is 7.67 divided by 1 and it comes out to be 7.67. Our next step is to find the relative numbers of atoms. Relative numbers of atoms in this compound. How do we find? By dividing the smaller ratio by all other ratio, we get the relative numbers of atoms. In these two ratios, 7.67 is lesser in number, so we have to divide this ratio by other two. So 7.69 divided by 7.67, it is approximate equal to 1. And when we divide 7.67 by itself, it also comes out to be 1. So, this 1 and 1 are the relative number of atoms of carbon and hydrogen which are present in the empirical formula. So, the empirical formula of the compound is CH, as in this empirical formula, one carbon atom as well as one hydrogen atom is present. Therefore, the empirical formula of the compound is CH. Up to now, first of all, we have to find the mass of carbon and mass of hydrogen. From the help of the masses, then we have to find percentage of carbon and hydrogen. After finding the percentage of carbon and hydrogen, we have to find empirical formula. Our next step is to find molecular formula and molecular mass. So let's find the molecular mass of the compound next. Its empirical formula is CH. Now our next step is to find its molecular mass or molar mass. Molar mass means mass of 1 mole of gas. Molar mass means we have to find the mass of 1 mole of gas. How do we find the mass of 1 mole of gas? For this, it is given to you a volume of 10 liter has mass 11.6 gram, and you know that volume of 1 mole of gas is equal to 22.4 liter. We have already known that the mass of 1 mole of gas, the volume of 1 mole of gas is 22.4 liter. In this question, the mass of 10 liter of this gas is given to you. So solve this for 22.4 liters. How do we solve? In this question, volume is given to you and you have to find the mass. So put mass on the right hand side and volume on the left hand side. How do we solve? For this, 10 liter of gas has mass equal to 11.6 grams. 10 liter of this gas has mass 11.6 gram. It is given to you in the question and you have to find its molecular mass. So 11.6 divided by 10. 1 mole means the volume of the gas is 22.4 liters. So the mass of 22.4 liter of this gas is equal to 11.6 upon 10 multiplied by 22.4. When you solve this, you get 26 gram. When you solve this, 11.6 multiply by 22.4 divide by 10, it comes out to be 26 gram. It means the molecular mass or the molar mass of gas is 26 gram. The molar mass of this gas is 26 grams. Now the last, we have to find the molecular formula of the compound. At last we have to find the molecular formula. For molecular formula, we have already found the molecular mass and empirical formula. So first of all, we find the empirical mass of the compound. Empirical mass of the compound is 12 plus 1, that is 13 grams. And molar mass or molecular mass of the compound is 26 grams. We know that there is relationship between empirical mass and molecular mass. When we divide molecular mass by empirical mass, we get the value of N that we have taken from the molecular formula. Here molecular mass of the compound is 26 and empirical mass of the compound is 13. So value of N by solving this comes out to be 2. The value of N is 2 and we know that molecular formula is equal to N into empirical formula. Now the molecular formula is equal to 2 into CH. CH is the empirical formula of the compound. So the molecular formula is C2H2. In this question, we have to find the empirical formula of the compound, that is CH. Molar mass is 26 grams and last we have to find the molecular formula, that is C2H2. In this question or in this statement, percentage is not given to you, only the elements are given to you. So first of all, you have to find the percentage of these two elements. Next you have to find the empirical formula. For molecular mass or molar mass, it is given to you 10 liter of this gas has mass 11.6 grams. So for 1 mole you have to find the mass of 22.4 liter and at last you have to find the molecular formula of the compound. I hope this question is clear to all of you. Thank you.